This lesson deals with supplemental problem 6.2. You can find this problem in the course ebook in the Chapter 6 supplemental problems on page 2. In Chapter 6, around page 6, we introduced a high-pass filter using a resistor and a capacitor. We can do the same thing with a resistor and an inductor. Let's just see if that makes sense. Suppose that the value of frequency gets smaller and smaller. So the impedance of the inductor is j omega L. As omega shrinks, this becomes more and more like a short circuit. On the limit, as you approach DC, this becomes a short, and the output's equal to 0, no matter what the input is. We block the signal. As the frequency gets higher and higher, j omega L becomes more and more like an open circuit. No current flows, because we've got nothing here. The output equals the input because the voltage across here is 0. This seems to be a high-pass filter. Could you sketch the magnitude of the ratio of V out to V sub S and the angle of V out to V sub S versus omega? Well, we have a voltage divider. The output voltage is j omega L divided by R plus j omega L times the input V sub S. Let's divide numerator and denominator by R. That'll make this a 1. Then we'll have j omega L divided by R. And in the numerator we'll have j omega L divided by R. In Chapter 6 on page 8, we define the form of a high-pass filter. It's j omega over omega C divided by 1 plus j omega over omega C. For the value of 10 ohms and 100 millihenries, then omega C is going to be 10 divided by 100 milli. 1 over milli is 1,000, and this is 1/10, so it's 1/10 of 1,000, or 100 radians per second. Now in Chapter 6 on page 7, we actually sketched the Bode plot of this general form. It has this shape with two straight lines as an approximation. The actual curve is the dotted curve, and right here is what we call omega C. In this case, that's going to be 100 radians per second. If you divide that by 2 pi, you get 15.92 hertz. That's the lower end of the audio band. So this circuit's passing everything above about 16 hertz. We also, from the general form, sketched the angle, and that was on page 8 of Chapter 6, where if we go back to omega C, and go back a decade, we're about 90 degrees. If we go forward a decade, we're roughly at about 0 degrees. And the slope between these two is 45 degrees per decade, but negative. And this is supplemental problem 6.2.